Good afternoon, everyone. We will continue our discussion on pointers. Okay, yesterday we started with the fundamentals of pointer concept in C. So, what are pointers? Pointers are variables only, but there are some special variables used for storing memory addresses. Memory addresses specifically, addresses are numbers, and normally we store the addresses of other data variables. Pointers are variables, or they are also called pointer variables, special variables for storing the addresses. Addresses of what? Normally we store the address of data variables. If I have here x is a data variable where I store some data, and I can take the address of this using the operator ampersand. So if I put ampersand x, I get the address of the variable x. Normally the address of the starting byte. If 2 bytes are allocated to x, address of the starting byte is obtained. And to store such address values, we use pointer variables. Okay. So here is a data variable x with the value 10. Then I declared a pointer variable how using a asterisk symbol before the variable name. Here is the data type, asterisk symbol to or star symbol to indicate that this variable is a pointer variable and it is expected to store addresses, memory addresses. Now once I declare the variable, I can assign the address of variable x in this manner: px equal to ampersand x. Ampersand x gets me the address of variable x. So in this case 1000, the address of the first byte. I am assuming this is the first byte of the 2 bytes allocated to x. Now once I have the address stored in my pointer variable, I can access the data stored or access the data stored in x using the pointer variable also. Now what I do is, initially x is having the value 10. Because of this initialization, x is having the value 10. Now I am accessing the using the pointer variable. I am accessing the value or location of x and updating the value. So this is a process called dereferencing. So I dereference the destination. So when I am doing this, effectively what I am doing is I am connecting this pointer variable to variable x with this statement. So it's as good as putting an arrow from here to here. So now pointer variable px is pointing to variable x. I can access this data either using variable x, variable name x, or using the pointer variable px. So this is what I am doing, accessing the data or modifying the data stored here using the pointer variable. So when I do execute this, what happens is this will be changed to 50. Now when I am printing, I can either use variable x to access the data or pointer variable px to access the data. So in case of px I am using, I have to apply star px dereferencing to get the data. The output will be this 50. Or if I use variable name x, then also the output will be 50 because the pointer variable pointing to variable x. So this is the fundamental concept yesterday we saw, and we saw the code also, each step what we are doing. Okay, same thing what is shown in the ppt. Create a variable, create a pointer variable to store the address, take the address of variable x and assign it to the pointer variable. This way now px is pointing to x. So you can access the value 10 using this way, using the xol or using px. If you want to access using variable name x, the normal way what we used to do. If you want to access using pointer variable, you dereference it. This is called dereferencing, getting the value stored in the destination of the pointer variable. Destination of the pointer variable is variable x. What you see here, the destination. This is pointer variable destination. So when I do this statement, one more the actually what happens is, in pointer variable 1000 will be stored. 1000 is the address of x. Address of x is 1000. That when I do this assignment operation, address of ampersand x gives me 1000. That 1000 will be assigned here. Okay, the real address values may be large values than this. Just for example, I have shown in the PPT. The same process happened here. Px is pointing to variable x now due to this statement. Then I am accessing the data. These two statements will print same value. What will be the value? These two statements will print the same value. Can anyone tell what will be that value? What is the value of x? 10. Value of x is 10. So now I have one more mechanism to access that value, my pointer variable. So both are going to print 10. 10. Okay. Now I'm modifying. Use the value stored in x I want to modify. Either I can put x is equal to 50 or I can put star px equal to 50. So 10 will be replaced with 50 now. That's what we are doing here. So 10 will be replaced with 50. Then I am printing again star px as well as x. Now both places I should get 50. I get 50 in both places, star px as well as x. Now size of the pointer variable is, yesterday I told, it need not be same as the size of integer. Size of integer is 4 bytes in my machine, but size of pointer variable is 8 bytes. Because we are storing memory address. Memory address, the length of the memory address or size of the memory address will decide size of a pointer variable, because in pointer variable we are supposed to store memory addresses, and the system I have is 64-bit machine, and a memory address will take 64 bits or 8 bytes in a 64 bits means 8 bytes in, and since my machine is 64-bit machine, it requires 8 bytes for storing a memory address, or length of a memory address is 8 bytes. So when I print size of a pointer variable, I get 8 bytes. Okay, but size of a normal variable is 4 bytes only in my machine, 32 bits. Now these are all about integer variable and pointer to an integer variable. So that is how I created int star. Now if you have a character variable, you create a character pointer. If you have a floating point variable, you create a float star pointer variable name, like that. So based on the destination data type, destination is a character variable or character data, I need to decide what is the type of the pointer variable. Okay, even in that case, in pointer variable I am supposed to store address only. Okay, memory address only. For character variable or integer variable, memory address will be of same size. Because of that, size of the pointer variable in this case also will be 8 bytes, because we are supposed to store memory address in this pointer variable also, and memory address is fixed size irrespective of the data you store there, 64 bits or 8 bytes. If I run this, so I should be PCH, I'll call it as PCH. So size of integer variable, integer pointer as well as character pointer, both are 8 bytes, because we are storing memory address, and size of memory address is fixed, not dependent on the data you are storing there. Irrespective of whether it is character or integer, the memory address will be 8 bytes. Yeah, then accessing using the character variable name ch, or by dereferencing the pointer variable. star PCH or CH, both should be giving me same result. PCH, char PCH equal to A, CH equal to A. This is the fundamental concept of pointers. Okay, so this looks to be a good program for your assignment. You can take a snap. I will also make an entry in my so 26th program of your assignment. Pointer basics. Okay, so it has all the description also. So if you understand this program, most of the things related to pointers is clear to you. Any question there? Okay.
No, sir.
Okay, if no question, we will proceed to uh, further topics. So one thing is, now when I created a integer variable and I created a pointer and I made the pointer point to the integer variable. This diagram. That is what is done. Now this pointer variable need not always point to this data variable only. Okay. At present this pointer variable is pointing to this data variable x, and if I print the value, I get star px equal to percentage d. So this prints. Okay, I made a mistake here. Okay, I'll revert everything because it's my assignment focused page. Okay, we're back here. So if I run this, I get output 10 because pointer px is now pointing to data variable x. Suppose if I have another variable int y equal to 100, I can make the pointer variable now point to y. First, I make the pointer variable to point to x and I access it. Now I am changing that my pointer variable. I am altering it and making it to point to another variable y. Okay, so this way you can reuse your pointer variable. It need not always point to same data variable. It can point to another variable of same type. Okay, now if I print it, star px, what should be the output? 100. So what happened is, I can show it in that PPT. When I created y, or I'll when I created y, I got another variable here y, and the value is 100. Okay, now when I do star px equal to ampersand y, when I do px equal to ampersand y, what happens is, suppose this y is at address 1010, 1010 or 1004, let's see, 1004. Y. So this is new variable y and the address is 1004 and the value is 100. Now when I do px equal to ampersand y, what happens is this connection will be disconnected and it will be pointing to this. So initially when I execute this, this is px is pointing to this variable. Now when I later in the program when I do, this is pointing to, px is pointing to y. Now if I do star px, y value px is pointing to y now. So if I do star px, I should be getting 100. When this was pointing, px was pointing to x, I got 10. Now px is pointing to y, I got 100. So essentially what I mean to say is your pointer variable can point to any variable at different point of time. At one point of time it can point only to one variable, but different point of time it can point to multiple variables, different variables. So here pointing to x, here pointing to y. Now if you create another variable z, and you can make it point to that also. Okay, so this connection is disconnected. Simultaneously this pointer cannot point to this and this. Either this, either to x or to y. Okay, that is the new concept we discussed today. Any question? No question, I guess. Now actually we have already a mechanism for accessing the data 10 or modifying the data in that memory. That is the variable name. What is the point in creating one more mechanism? We are here in this function, x is there, we assign 10. If I want to modify it to 100, I can do x is equal to 100 rather than use creating a pointer and doing star px equal to 100. So real benefit of using pointers, not in this way. Here we just understood that you can create a pointer variable and make it point to the data variable and access using the pointer variable. But the real use is not there because just it is redundant, right? Repetition. I have one mechanism to access the data and modify the data. Why? What is the use of creating one more? The real use of this is coming in user defined functions. User defined functions. Okay. When we create user defined function and pass, say I have a function called modify, and it takes int x and x equal to 100 I am doing. So we'll remove all these things and call the function modify x. Before sending, I will print the value of x. After calling modify, again I am printing the value of x. Okay. Can you tell what will be the output in both these case? Or I'll make it as y. Okay. Can anyone tell? Okay, here let me not return anything. No, void. Can anyone tell what will be the output in this case? Here it is obvious, x is going to be 10. After this I'm calling the function modify, and now again I'm calling the printing the value of x. What will be the value printed here? Can anyone? What will be the value printed?
10 only.
10 only. 10 only, because we learned call by value. When we are passing this argument into this function, what happens is value of x, x and y are actually totally different variables. Value of x, that is value stored in x, 10, will be copied into y. Now when I am modifying, y is getting modified, x is totally independent and x is available in function main. Y is available only in function modify, x is available only in function main. So they are totally independent. So if I make a change to y equal to 100 here, it is not going to affect the original variable x. So we had studied this. This is called call by value. Only the value is copied from this to this variable. Okay. Now, what if we want to make a change to this variable within this function? Within this function. In that case, what we can do is we can pass address of this. We can pass the address of this variable into the user defined function. Okay, so that is called call by reference using pointers. So what we need to do is we should pass the address of x. How do we get the address of the x? Using ampersand. Using ampersand, I get the address of the x, variable x, that you know. Now this is an address now. So because of that, I cannot store it in a, or I should not store it in a data variable. This is a data variable. So instead of that, what I do is I change it into a pointer variable or star p. So what I am doing, normally I was passing a variable modify in bracket argument is x. Instead of that, what I am doing is passing the address of variable x, and that since it is address we use pointer variables for storing the address. So address we that is getting stored in the pointer variable. So here we make it as int star p to indicate that this is a pointer variable, and the value coming in from the main function is an address. Okay, now what I do is I modify using this is dereferencing, and this we did in the previous program also. Star px equal to 100. If I have a pointer variable, star px equal to 50 I did. Same thing I am doing here. Star p, here variable name is p, pointer variable name is p, star p equal to 100. Now what happens? P has an address, and in that address data value 100 is put, or where the address that is corresponding, or in the location that is corresponding to address stored in p, we are putting 100. So in this case, the output will be, second time the output will be 100. What actually happened, we took the address of the variable x and passed into this function. Using that address, we dereferenced and put a value there. Once I am back, I am printing using x. I get a modified value. This is the real use of pointers. And this is called call by reference using pointers. Okay. Now I will try to portray that in the diagram. So probably I'll take that code only directly. Oh. Okay, I have a variable and x I am assigning it to 10 initially. Here main is executed first, x is equal to 10. Then I created this is in, so x belongs to main function. So x belongs to main function, so I'm taking the whole thing towards the main function. No, I don't need this anymore. So x is created and it is assigned with 10. Now to the modify function I am passing address of x, that means what, 1000 I am passing. Address of x is 1000. Now what is there? I call it as p. In the modify function I call it as p, and 1000 which I am passing here, that gets stored in this. Maybe assume that pointer p is in 1020. This is also a variable that is at address 1020. This is not significant here. So essentially what I am doing, this pointer p is pointing to x now. So initially only x is there. Okay. So where we were. So variable x belongs to this. Variable x belongs to main function, and I am passing the address of x, that is 1000. Here example is 1000, and in the called function pointer p is receiving that value. So in p 1000 gets stored. Effectively what we are doing is pointer p, we make it point to x. X belongs to this function, but the pointer p belongs to this function, but we are making it pointer p point to x this way. And when I am doing dereferencing star p, it is referring to this memory, and if I put star p equal to 100, this data value gets changed. Okay. Now once this function returns after the execution, it will return to this place, right? This place. Here I am printing the value of x, so what I get, 100. This is the reason why when I am executing it I get 100 as the value. Okay, is it clear? This is called call by reference using pointers. We studied call by reference using array. When we learned arrays or user defined functions, call by reference using arrays we studied. There when we pass an array into a function, by default it is call by reference. Here there is only one variable associated. What we do is, how do we achieve call by reference is, pass the address of the variable into the function, store it in the called function, store it in a pointer variable. The formal parameter is a pointer variable. Now p points to this x, and we modify or access the value or modify, either both the things we can do. So if I print here star p star p equal to percentage d, data is an integer, because of that I put percentage d star p. So in modify, okay, so if I put a slash in there, so before modification I am printing the value here. So before modification I get the value 10, because 10 is assigned to x. So after that I modify it, and when I am back here I am printing the value of x. So I get 100. This is called call by reference using pointers, and this is the real use of pointers. Otherwise creating a pointer within the same function does not have much of a value addition, because anyway we have access to the data using the original variable name. We don't need an additional pointer variable. Okay, any question about call by reference using pointers?
No, sir.
Okay, this is the scenario we have created. Now, yeah, next one is pointers and arrays. There is some relationship between pointers and arrays. So shall we take this example as another assignment question? Prints 100, prints 10, again prints 10. Okay, so this looks to be a good example to refresh the concept of call by reference using pointers. So the advantage is that once you are used to this program, whenever you later the concepts you will forget, but just go through this program, you will immediately remember that. Okay. So I'll just save it as a next assignment pro question 27. So don't worry about you are getting so many assignment questions. Basically, this is for your benefit only. Okay, you will once you write it, you will get much better idea, and you will have a reference in your hand whenever you want to refer to this concept. Okay. So next topic is there is a relation between arrays and pointers. Arrays and pointers. Okay. So for that, I'll create an array here. Say 5 is the size of the array, and I'll initialize with some values. I have an array, or I'll make some other value here, 7, 8. Now when we create an array like this, internally the name of the array is treated as an integer pointer. The compiler treats it x as a pointer, in fact. Okay, and since a pointer has to have an address, or a pointer is used for storing the address stored in x will be the starting address of this array. Starting address of this array. Starting address means address of the first element in the array, so or address of this one. So compiler internally treats it as a pointer. For us it is an array, and x is the name of the array. For compiler, the type of this x is int star, or x is internally treated as an integer pointer. Okay, so to probably to prove that, I will print the value of x. X is the name of the array, it's not a data variable. I'll print the value of x. X is equal to %d. And we'll see what is coming. What is it coming? X is equal to ampersand. Oh, sorry, %d I should put. Okay, see, I get an address. So this is the starting address of this array. Array also will be assigned in allocated in the memory, right? Array will be allocated, and it will also have an address, starting address. So starting address of an array is address of the first element. So to prove that, we will take the first element and print its address. So first element is x of 0. For this array, first element is x of 0. And how do we get the address? Using ampersand on x of 0. So I'll run this again. I get the same value. So when you declare an array, the name of the array is internally for compiler implicitly compiler treats it as a pointer. It as a pointer, and the address stored in that is the address of the first element of that array, or we call it as the address of the array, starting address of the array. So when I'm printing x as well as ampersand x0, x0 is the first element or first variable of my array, and address of that is obtained using ampersand. So both I'm getting the same value. Okay, so that is the relationship between an array and a pointer. When you declare an array or create an array, name, if you take the name alone, it is actually a pointer variable. Pointer, it's actually a pointer, and it stores the address of that array or starting address of the first element of the array. Clear? Any doubt? Okay.
No, sir.
So one more thing, if I want to display the elements of this for, okay, this much is done. I'm going to display the elements of this array for int I is equal to 0. I can declare here also. Okay, I don't need to declare I always here separately. Here also I can. Okay, it may not be supported by all the C compilers, so I'll rather put it here. I less than 5 elements are there, I plus plus, and I'm going to print it. Percentage D. What should be that? X of I. I print all the elements 1 2 7 4 8. Now since it is a pointer also, what I can do is I can create a pointer in the star p or px and assign x to that. Remember, x is an address, so I don't need to again apply ampersand on that. I don't need to apply ampersand again on that. See, that itself is an address. So what I do is I create a variable px and initialize with the x, or I can separately write it semicolon here and px equal to. These are two ways. I can directly initialize it this way, in the star px equal to x. This way I can do, or separately I can do. First declare, then assign. Okay, these both are possible. Now px will become another name for this array. Px will become another name for this array, and I can display all the elements in the array using px also now. So x is actually a pointer pointing to an array. The name x is actually a pointer internally. So because following the same concept, I created a new pointer, and the address stored in x, the address value in x, I am assigning to px. Now I am going to access that array using px only. You'll see. So here I'll put a /n to print it in a new line. Okay, so if I run this, I get. So what is happening? The original array name, using that I am printing it using the original array name x of I. Now the address values in x, that is this address value, I am storing into another pointer variable px. Now I am accessing the elements using px now. Because of that, now px as well as x both are referring to the same array. Okay, so diagrammatically if I show, let's forget about this. X is an array. It's an array now. Px, assume that the starting address of this array, the first element's address, that it is 1000. Now px is also, so this array I call, this is x is actually internally a pointer pointing to this array. So when I do x0, when I do x0 I get this, when I do x1 I get this. Now px, when I am doing px equal to x, in the star px equal to x, this is also pointing to the same array. So if I do x0 I get this element, x1 I get this element, x2 I get this element. Similarly px0 I get this element, px1 I get this element. Okay. So this is for the declaration x as array in x of 5. When I do this, so going back to the code, px as well as x both are referring to the same array. Px as well as x both are referring to the same array, and we are able to access all the elements, or if I want to modify also I can do it. Here I am just accessing and printing it. I can modify also. Px of I equal to some new value, if I put, that will come. So essentially there is a correspondence between pointers and arrays. Name of an array is implicitly a pointer variable. Internally it's a pointer variable for the compiler, and it stores the starting address of the memory space corresponding to the, this is the memory space corresponding to the array where the data is actually stored, and x is pointing to this one. Any question? So here we started with call by reference using pointers, then we moved on to relation between pointers and arrays. An array name is treated as a pointer by the compiler. That stores starting address of the array. Okay. Any question in this? So if not, what is left? Pointer increment factor. It is an SLE. We will discuss in the next class. Pointer increment factor.